Hello friends, welcome to this course on generative AI and prompt engineering. This is session 2, Introduction to Machine Learning. This is a comprehensive course on generative AI and prompt engineering. My name is Ram. This session 2 is about machine learning. In the previous session, we learned about what is artificial intelligence. And in the next session, we'll start working on and understanding the generative AI part. This is a kind of prerequisite. So these two sessions, the first session and the second session, is basically prerequisite for generative AI and prompt engineering. So this is session 2. Welcome to this session, Introduction to Machine Learning, and the complete comprehensive course on generative AI and prompt engineering. What is machine learning? Machine learning is a subset of artificial intelligence that focuses on creating computer systems that can learn and improve from experience, powered by algorithms that incorporate intelligence into machines. Machine learning is all around us. Machine learning provides statistical tools to analyze, visualize, and make predictions from the data. There are two ways. One is you train the model, you train the machine based on the existing data, and then you use that knowledge of the machine to inference the results based on your query. So whatever query you have, based on what the machine have learned, machine will respond. Second is you don't train the machine learn on its own in the given data and the pattern in the data, and then you use that knowledge acquired by the machine to segment specific target audience or customers. So online shopping, you will see machine learning. And if you have watched Netflix movies, if you watch one particular genre of movie, next time you'll start getting recommendation of that kind of movies again. So that Netflix movie suggestion is also a good example of machine learning. Spam mail warning is another example and use case of machine learning. And if you see self-driving cars, which are very common in the United States now, is again an example of machine learning. So machine learning basically consists of two parts. First part or the first phase is the training, where the learning capability from the existing data, that's the training part. So for example, you have a training data set. As an example, if you have some animals like cats and dogs, so that data along with their label, like this is the cat, this is dog, and with all the features, so you train the model on all the features of cats and dogs, like ears, eyes, nose color, body, everything, and the machine learn those features of dogs and cats. So during this process, machine learning algorithm is able to learn the various features of these animals. Now once the model is trained, you can use this trained model for inference, which is applying this capacity or capability to the new data. So in that process, if you input a dog or a cat image input data, then trained model will predict that this is actually a dog. So this is basically where you train the model on the various features and characteristics of various animals along with the data and the labels, and then you use that knowledge acquired by the model to infer results based on your own input or your own query. Machine learning and its use cases, like one is supervised machine learning, which is used in disease detection, weather forecasting, stock price prediction, spam detection, and credit scoring. This is a kind of machine learning where the supervised learning is where classify the data or make predictions. Unsupervised learning is which is used in fraudulent transaction detection, customer segmentation, outlier detection, and target marketing campaigns. Here, understand the machine learning algorithm, understand the relationship with the data sets. And the third one is reinforcement learning, which is used for automated robots, autonomous cars, video games, and healthcare. this is the model where this is the process where machine learn based on the penalties and rewards. So we call it as make decisions or choices, and based on the decision or choice the machine learning algorithm make, we penalize or we reward it. So this reward and penalty process makes the model competent enough to take decisions always in the right direction and in right format. So let's talk about the supervised machine learning. Machine learning model that learn from the labeled data. So you give the labeled data and you make the model learn with the labeled data. For example, house price prediction. You enter the house prices based on various parameters like size of the house, location of the house, and various other parameters, and then you ask the model to predict the price based on your own question, like I'm looking for price of the house in this area with this size with these number of bedrooms, and then the model predict the price based on your input data. Then another example is disease detection. For example, you train the model on various features or symptoms of various disease, and then you ask the model by entering the symptoms of a disease and ask the model to predict the disease. Another sentiment analysis and stock price prediction. These are all examples of supervised machine learning. Now, as an example, predicting house price based on the house size, we can scatter plot aid, which aid in visualizing the relationship between input and output. This is where we use this in predicting the price of the house. Like for example, we can fit this line, whether this is the line, right line, or this is the line, or this line. We predict the line based on the points scattered on the plot. So this line, for example, this line is the best line right now, which is near to almost all the points, where all the points are almost on the line. So basically we can say that once the line is properly fit, the predicted price will be on the line, but actual price might be slightly different. For example, these are different prices which are different, which are slightly away from the line. And this is the sample data. For example, house size is 1400 square feet and the price is 220,000, 1800, 300,000, and so on and so forth. Minimizing the loss is the main objective during the learning process. Loss is the number indicating how far the predicted value is from the actual value. For example, the actual value is value denoted by these bars, these points, where the predicted value is actually on the price. So this is the predicted value, this is the actual value. So objective is to minimize the loss, and the scared error is used to minimize the loss. The scared error is actually the scared difference between the predicted point and the actual data point, which needs to be minimized during the training process of the model. Second type of machine learning is unsupervised machine learning. It is a type of machine learning where there are no labeled data for the model. Algorithm learns the pattern in the data and to predict the odd man out or outliers from the data. So which means that model is able to group the data with similar data items and leave behind other data which is not from the given data set. So this can be done using clustering. One technique is called clustering, where clustering is the grouping of similar data items. Here the data items that are more similar within a cluster than the items outside it. For example, if this is the raw data, the algorithm will learn and will predict the items which are similar or of the same type and the outliers. This is the clustering. Second is similarity. Similarity is how close two data points are to each other. This similarity is always, the value of similarity is always between 0 and 1. The use cases of unsupervised learning: one is market segmentation, where we input purchasing details, identify similar customer based on the purchasing behavior. The output and the results and the implementation of this kind of process is targeted advertisement for the customers. Second is outlier analysis, where we input the credit card purchase details and identify fraudulent transactions. So output here is the anomaly detection. Third one is a recommendation system, where we input the user's movie viewing history and identify users based on the genre of the movie watched, and therefore here we can use it for personalized movie recommendation system. So these are three good use cases of unsupervised learning. One is market segmentation, outlier analysis, and recommendation systems. So the workflow for unsupervised learning is: first we prepare the data, we remove missing values, normalize the data, and perform feature scaling. Then the second phase is create similarity matrix, where we choose a similarity metric based on the nature of data and clustering algorithm used. The third phase is we run the clustering algorithm, where we use the chosen similarity metric to cluster the data, and finally interpret the results and adjust the clustering. Check the quality of your clustering output by verifying against expectations iteratively to improve the results. Then the third one is reinforcement learning, which is a type of machine learning that enables an agent to learn from its interaction with the environment. It receives the feedback in the form of rewards or penalties without any labeled data set. Reinforcement learning examples are autonomous vehicles, smart devices, and industrial automation or robotic arms, or gaming and entertainment. Some terminology: the terms which use in reinforcement learning is: one is the agent. This agent interacts with the environment, it takes actions and learn from the feedback. Environment is the external system with which the agent interacts. State: it is a representation of the current situation of the environment at a particular time. Action: possible moves or decisions that the agent can take in each state. Policy is a mapping that agent uses to decide which action to take in a given state. So for example, this is an example of robotic arm. To train a robotic arm using reinforcement learning, the step 1 is environmental setup. During this process, we set the robotic arm warehouse layout, goods, and target locations. Then state representation. State include position and orientation of the arm, items to be picked, and the targeted location where the items are to be placed. Step number 3, action space. It defines the possible actions the robotic arm can take in each state. And step 4, reward and penalties. It learns by rewards and punishments. And final step is training and iterative improvement. It starts in a random state and take actions in the environment. So through multiple learning iterations, the robotic arm learns better strategies for picking up and placing the items in the warehouse. This is a very good example of reinforcement learning. That's all for this session. Thank you very much for watching.